Hello everyone and welcome to this presentation on modulation techniques. Today we will break down on modulation methods, explaining how they work and showcasing the essential modulator and demodulator circuits involved. Well, also dive into a comparisons between analog and digital modulation, helping you understand the core concept in the clear and engaging way. Let's get started. So today we will be discussing about uh, what is modulation, AM, FM, PM, and digital modulation, and we will then last we will compare and do a conclusion. Before we dive into a specific of each modulation technique, let's define the modulation in simple terms. Of modulation is a process of varying a carrier signal's properties such as its amplitude, uh, amplitude frequency, or pace on transmit information. This ensures that the signal can travel long distance with the minimal loss and interference. Essentially, it is the technique that allows us to transmit the data effectively over a communication medium that whether that's a wire, radio wave, or even fiber optics. Let's start with amplitude modulation or AM. In AM, amplitude of the carrier signal is varied in the proportion to the message signal. The result is a modulated signal that is contains both the carrier and the sidebands that carry the actual information. Here's how it works. The modulator circuit consists of a mixer which combines message signal with the carrier. The demodulator circuit typically uses a diode detector to extract the message signal from the modulated carrier. AM is widely used in radio broadcasting, but has limitations such as being more susceptible to noise and interference. Next, we have frequency modulation or FM. In FM, the carrier signal frequency is varied according to the amplitude of the message signal. Message signal instead of its amplitude like in AM. This makes FM more resistant to the noise and interference, which is why it is commonly used in high fidelity audio transmission like FM radio. The modulator circuit uses a voltage control oscillator or VCO, which adjusts the frequency of the carrier in response to the message signal on the receiver side. The demodulator circuit is typically uses a phase lock loop (PLL) to recover the original signal. FM offers higher quality resistance to the interference compared to AM, but requires larger bandwidth. Pace modulation or PM is similarly to FM, but instead of varying the frequency, we change the pace of the carrier signal based on the message signal's amplitude. PM is commonly used in digital communication system and is closely related to the frequency modulation. In the modulator circuit, a phase modulator introduces shift in the carrier phase. To demodulate the signal, the demodulator circuit uses a phase detector that compares the phase of the received signal to a reference. PM primary advantage lies in the ability to handle noisy environments effectively. Now let's switch gears and talk about digital modulation techniques. In digital modulation, the information is encoded into the discrete signal rather than the continuous ones. Let's look at two common methods. Binary phase shift key (BPSK). This is where the phase of the carrier is shifted by 180 degrees to represent the binary data. Quadrature phase shift key (QPSK). Here, four different phase shifts represent two bits of data at once. These techniques are used widely in satellite communication, and Wi-Fi digital modulation is known for better efficiency, noise immunity, and scalability compared to analog modulation, especially for data transmission. Let's compare the analog and digital modulation methods. Here are the key differences. The bandwidth analog modulation requires a broader bandwidth compared to digital modulation, which can transmit more data, same space. Noise-resistant digital modulation is generally more resistant to noise and interference, making it ideal for high-speed and long-distance air transfer. Complexity digital modulation schemes are more complex but offer better error correction and greater efficiency in data transmission. To sum it up, modulation techniques are the backbone of the modern communication system, enabling us to transmit data efficiently across long distance, whether using analog methods like AM, FM, or PM, or digital methods like BPSK and QPSK. Each technique has its advantages and limitations. By understanding how modulator and demodulator circuits work together, we gain insight into the technical foundation of the communication system. Thanks for watching, and I hope this presentation helped clarify the modulation concepts for you. So, thank you very much. Uh, like and subscribe my channel. Thank you.